Hello students, and welcome to the third video of this four-part series. In this video, we're just going to do a ton of practice problems using that quotient rule that you just been learning about. So let's get started. All right, so as we're going through these problems, we want to find the derivative using the quotient rule. All right, so let's get started into this problem, and I'm just going to go straight into it. So f prime of x, that derivative is going to be low, so x plus 2, d high, so the derivative would be 2x minus 2, minus high, so x squared minus 2x, d low, so times 1. Square the denominator, so x plus 2 squared, and let's keep going. All right, so I've got to multiply some of these things out, so 2x squared first outside, so that's minus 2x plus 4x, so plus 2x, and then minus 4. And then over here, I have minus x squared plus 2x, all divided by x plus 2 squared. And let's combine some of these like terms. So 2x squared minus x squared, I get x squared here. 2x plus 2x, I get plus 4x, and then minus 4. Divided by x plus 2 squared. And there doesn't seem to be anything else that I can combine or simplify here or factor. So that's going to be our final answer. All right, moving over here to our second problem. I want to find g prime of x, and again, that's going to just be an application of the quotient rule. So let's start this. That's going to be low, so x plus 2, d high. So the derivative of tangent is secant squared, x, minus high, so tangent x, d low, so times 1, and square that denominator, x plus 2 squared. And let's just get rid of some of these parentheses that I can. So x secant squared x plus 2 secant squared x minus tangent of x. Divide all that by x plus 2 squared. And although it doesn't look pretty, there seems to be more letters than numbers in this case. That right there is going to be our final answer. So be comfortable like leaving your answers looking, not so neat. And that's a lot of calculus, is not leaving your answers in a very neat spot. Just because at some point you're going to pound your head against the wall trying to simplify things that can't be simplified. All right, here we go in our next problem. And we want to find this derivative, so h prime of theta, all right? And that's going to be 1 minus cosine theta times the derivative of sine is cosine minus sine theta, and then the derivative of the denominator. So that's negative cosine, and the derivative of cosine is negative sine, so negative, negative, so I get sine here, so sine theta here. And then square that denominator, 1 minus cosine theta squared. All right, there should be some things I can simplify, so I get cosine theta minus cosine squared theta minus sine squared theta, all over 1 minus cosine theta squared. Equals, all right, so in that part right there where it says cosine squared theta minus sine squared theta, I feel like if I factor out a negative, I can simplify this a little bit. So I'm going to do that. So cosine theta minus, and then put some parentheses around that, plus sine squared theta, all divided by 1 minus cosine theta squared. All right, as we're going through this, so the reason I did that is because I can now write this as cosine theta minus 1 over 1 minus cosine theta quantity squared. And remember, that's just from a Pythagorean identity. All right, and what I can do here to simplify this a little bit more, factor out a negative again, and I get 1 minus cosine theta, all divided by 1 minus cosine theta squared. Okay, so now in my numerator, I have 1 of these 1 minus cosine thetas. And in my denominator, I have 2 of those 1 minus cosine thetas. So I can divide those out, and I'm going to get -1 over 1 minus cosine theta. And that right there, although seemed like a lot of steps to get to simplifying this, that right there is going to be our final answer. So sometimes you get these intuitive feelings where you do want to pursue if things can get simplified, and in this case, they definitely could get simplified. All right, let's go over to the right side where we have another problem. And before I even get into it, I'm going to rewrite this as a negative x to the negative first power. And that's going to be really helpful as I move forward. So if I find this derivative, f prime of x equals x plus 5, and then the derivative of the numerator, so 3 is a constant, so bring that one down. So that is going to be positive x to the negative second, minus the numerator, so 3 minus x to the negative first, times the derivative of the denominator, so times 1. And I square that denominator, so x plus 5 squared. All right, and let's see where this takes us. So let's see, if I'm going to distribute everything, I'm going to get x to the negative first plus 5x to the negative second, and then minus 3 plus x to the negative first, all over x plus 5 squared. And what I can do with that is, because I have 2x to the negative first terms, so I'm going to write this as 5x to the negative second plus 2x to the negative first minus 3 all over x plus 5 squared. All right, so what can I do with this? I am going to try to write this all as one fraction. So let me start this idea, because that's going to be 5 over x squared. I'm just looking at the numerator right here. So 5 over x squared plus 2 over x minus 3 all over x plus 5 squared. Okay, so then if I multiply these so that they have common denominators, that's x over x and x squared over x squared. All right, so then I'm going to get 5 plus 2x minus 3x squared all over x squared all over x plus 5 squared. And what I'm going to do is I'm going to multiply this. I'm going to flip the denominator and multiply. So I'm going to multiply this by 1 over x plus 5 squared, because that's what you're doing when you're dividing by a fraction. All right, so I'm going to get this out, and that's going to be, let me see, negative 3x squared, because now like all my terms flipped around. So negative 3x squared plus 2x plus 5. And then my denominator, I'm going to multiply those out, and I'm going to get x squared times x plus 5 squared. And I think, just looking at it, this right here looks a little bit better than what was up there. All right, just a teeny tiny bit. Okay, so that's the whole point that we're going through this, is like the quotient rule ends up looking really messy. But you do need to be very comfortable with it, because these rational functions are going to show up all the freaking time. All right, so now we're going to use the quotient rule to show that we can get this value here, okay? So as I'm working on this, let's see what we can do. So we want to use the quotient rule here, and that's going to be f prime of x is low, so x squared minus 1, d high, so 2x plus 3 minus high, d low, so times 2x, square the bottom, and away we go. All right, so let's see what we can simplify here. This is going to be a long one. So that's going to be 2x cubed plus 3x squared minus 2x minus 3. And then I'm going to have to multiply all of those out. So that's going to be minus 2x cubed and minus 6x squared and minus 4x. All of that gets divided by x squared minus 1 squared. All right, so let's cancel out whatever I can. So 2x cubed minus 2x cubed. And then 3x squared minus 6x squared. That's going to be minus 3x squared. And then, let's see, negative 2x minus 4x. That's going to be minus 6x and then minus 3 all over x squared minus 1 squared. Okay. So what I notice here is that I can factor out, What I notice here is that I can factor out the negative 3 from that numerator. Let me bring that right over there. And let me do exactly that. So negative 3 in my numerator. And then I'm going to have x squared plus 2x plus 1. All divided by x squared minus 1 squared. Okay. And then in my numerator, I can factor that. So that's going to be negative 3. And I'm going to have x plus 1 squared. Now, in my denominator, I have x squared minus 1 in that parentheses, and that can be rewritten as x plus 1, x minus 1. And since they just get multiplied twice, since it just gets squared. So I just factored it and I distributed that exponent. And what I notice here is that these things are going to divide out, x plus 1 squared and x plus 1 squared. And so from this, I get negative 3 over x minus 1 squared. And that looks exactly like what I wanted to prove up here. And that seems like a lot of work. And the whole point of that is similar to what we were doing in the product rule. The whole point of this is that when we're working through these problems, you want to see if there are things that you can do first. For example, in this problem, I could have factored this first. So let me do this here. So f of x is equal to x plus 2 times x plus 1 over x plus 1 times x minus 1. And what happens is I have stuff that divide out before I even go. So that's x plus 2 over x minus 1. Now I still need the quotient rule, so that's okay. So f prime of x is low, so x minus 1, d high, so that's just 1, minus high, so x plus 2, d low, so just times 1 again. Square that denominator, so x minus 1 squared, and away we go. So here I get x minus 1 minus x minus 2 all over x minus 1 squared. Those x's cancel out, and negative 1 minus 2 comes out to be negative 3 over x minus 1 squared. And that was like so much faster than what I did a second ago. And it's just like the flow of it is much nicer. So this is why I always harp on getting down factoring early in algebra 1, early in algebra 2. Whenever you get it down, your life in calculus is going to be so much easier. So get that factoring down, continue to work on it. And if you need to get some problems with that, reach out to me. And so the whole point of this is, what lesson did we learn by doing that algebraic analysis, doing the factoring first and then using the quotient rule? And that what you should have learned is that a rational function can be factored and simplified before applying the quotient rule. Then you should just do it.
Do it! Just do it!
So it's a really important thing that you guys are going to note here, right? Factoring is super important, especially whenever you see any sort of problem. And especially as we start to tie in all of these different rules, you're gonna understand like how everything from algebra starts to really meld together. If you're struggling on the concepts and the practice problems that we were doing in these functions using the quotient rule, make sure you reach out to me for that clarification. My name is Mr. Hernandez, and this was Mr. Hernandez Teaches.